Good day. Physics Online Class SHS1 Strand, Scalars and Vectors. Today we will emphasize on scalars, vectors, examples of the two quantities, and we shall also compare the two quantities. Now let's stay focused and go through the rest of the slides. Scalar quantity. In science, you will encounter varying physical quantities. Some of these quantities are accompanied by directions, others are not. A scalar is a physical quantity that has magnitude but no specific direction. Now when we say a scalar has a magnitude, it means it has a size or it has a quantity, but it has no special direction. It is described by a single number with its appropriate unit. Now the unit is just defining the quantity, telling us the type of quantity it is, whether it is a quantity which defines distance, it is a quantity that defines mass, and so whatever the quantity would be, there should be an assigned unit to define that quantity. The unit doesn't give the quantity any kind of direction. It only defines the quantity. So if I say 7 meters, I know I am talking about distance or displacement. If I say 5 kilograms, I know I'm talking about mass of a body. Examples of scalar quantities are: we have mass, we have time, we have distance, we have energy, we have work, we have speed, we have density, we have volume. I can go on and give more and more examples. Let's add area. It's also a scalar quantity. So what I want to tell you, or what I want you to be aware of, is any quantity that can be defined by only the magnitude, any quantity that has only magnitude but no special direction. The quantity can move or can be directed to different directions. But if it is not specific, I can quantify the quantity as what? A scalar quantity. Scalar quantities can be added or subtracted using the rules of ordinary arithmetic. It means when I'm adding two scalars, if I have 3 meters and I'm adding 3 meters to 4 meters, I should use ordinary arithmetic. And so 3 meters, a distance of 3 meters plus 4 meters will give me 7 meters. Simple arithmetic. Now let's define some of the quantities, scalar quantities we mentioned. Distance. Now distance is how far you've traveled. For instance, or for example, walking from my house to school is 300 meters. It's a distance of 300 meters. Now distance has no special direction. It has a magnitude, and the SI unit of meters is assigned to the magnitude. Now let's take the second example, speed. Now, speed defines how fast something is moving. Now, I can say the car has a speed of 20 meters per second. Speed is a scalar quantity. It also has no specific direction. Meter per second is the SI unit of speed. It doesn't add any direction to the speed. The next example is mass. And mass is the amount of matter in a body. Mass has no direction. It has only magnitude. And so, if I should measure the mass of the mass of a stone, I'll get a value. And that value is the magnitude. And I have to assign the right unit. And so, measuring mass, I should add kilogram. The kilogram does not add any direction to the quantity. It only defines the quantity. And so, examples of mass, I give 10 kilogram. 10 kilograms. Another scalar quantity I will talk of is time. Time is duration. Examples of time is scalar quantity. Now, walking from my house to St. Hubert's Seminary will take me 1 hour, which is equivalent to 60 minutes. And that is also equivalent to 3,600 seconds. Now, the second attached to the magnitude, to the value, does not define or show or give any direction. Another example of scalar quantities is temperature. And temperature measures how hot or cold a body is. And if I measure the temperature of a body, it gives me only the magnitude. And so I need to assign the right unit. So example is 20 degrees Celsius. Now, temperature has SI unit of Kelvin. But other assigned units are also degrees Celsius, Fahrenheit, we have other examples of scalar quantities to be energy, work, power, volume, and density. Now, we are done with scalars. Now, let's talk about a vector quantity. A vector quantity is a quantity that has a magnitude and a specified direction. So, vectors are defined by two important features or characters. It should have a magnitude and it should also have a specified direction. Examples of vector quantities are displacement. Now, displacement is change in position from the start to end. Now, displacement is far different from distance. And in our next slides, we will talk about the differences between the two. Now, displacement has a magnitude and a specified direction. So, I can say I have been displaced by 5 meters to the north. Second example I'll talk about vector quantity is velocity. Velocity is Speed in a special direction. Speed in a specific direction. And so, in defining my velocity, I should get a magnitude, and I should also get a special direction. And so an example is the car is moving with a velocity of 20 meters per second to the east. Now let's take notice. I made mention of 20 meters per second, and I also made mention of a direction east. The next example is force. And a force is a push or pull. A push or pull on a body. Force is a vector quantity, and so force will have magnitude and direction. Example is, he pushed me with a force of 10 newtons to the south. Yes. Acceleration is also an example of a vector quantity. That is the rate of change of velocity. And so, an example of now let's compare distance and displacement. We've already mentioned that distance is a scalar quantity and displacement is a vector quantity. Now, distance is the measure of the path a body covers. Distance has a dimension of capital L or uppercase L and SI unit of meter. Distance is a scalar quantity and has only magnitude. Now, displacement is far different from distance. Displacement is the distance between the measure of your initial and final position. Displacement is a vector quantity and so has a magnitude and a specific direction. Now I can say displacement is also having the same dimension as of capital L as that of distance. And so it will also have the same SI unit of what? Meter. But we can attest to the fact that from the definition here, distance and displacement has the same dimension, has the same SI unit, but different definition. Now let's compare speed and velocity. In our everyday speech, we use speed and velocity interchangeably, but there are differences between speed and velocity. Now let me take speed and talk about speed. When we say the car is moving with a speed of 30 meters per second, what it means is that the car is able to cover a distance of 30 meters in a time of 1 second. Or the car is able to cover a distance of 30 meters within a time of 1 second. And so, the mathematical formula for speed becomes distance divided by time. Speed has no specific direction. We should take note. Now, velocity. Velocity is defined as the displacement per unit time. Now, so, I can say that the car is moving with a velocity of 30 meters per second to a certain specific direction. And now, let's stress on the mathematical formula for velocity. Velocity then becomes displacement all over time. And so if I can compare the two, speed and velocity, I can state that speed has two scalars, while velocity has one vector and one scalar. And so we should also know how to identify or how to recognize whether a quantity is a scalar quantity or a vector quantity. Now, velocity and speed has the same dimension. They both has the same SI unit, but different definition. And so, I can now differentiate between speed and velocity. I can also determine some similarities between speed and velocity. In our everyday vocabulary, we often interchange mass and weight, or we sometimes refer to one thing as mass and also weight. But there are differences between the two. Now let's begin with mass. Mass is the total amount of matter in an object. Yes, the amount of stuff in an object is mass. It's a scalar quantity and has only magnitude. Mass is also having a dimension of uppercase or capital M and SI unit of kilogram. Now, after this slide, you shouldn't use mass and weight to refer to the same thing or to refer to the same measurement. Mass is different from weight, even though we can relate them, but still there are differences between the two. The mass of a body does not change at any time. The mass of the body does not change at any time. If I am positioned anywhere in the universe, my mass, the amount of matter in me, will be the same. So the mass of a body does not change at any time. Now, the instruments used to measure mass, some of the instruments are, we have the beam balance and we also have the electronic balance. Yes, these are the two instruments we use to take the measurement of what? Mass. Now let's get to weight. Weight is the measure of force of gravity acting on a body of mass. Now, weight is a vector quantity and so it has a specified direction. The weight of an object is directed towards the center of the earth. Now we can relate weight and mass by the formula W is equal to mass times acceleration due to gravity. That is, weight is equal to mass of a body times acceleration due to gravity acting on the body. Now, with a mathematical relation between weight and mass, where W is equal to M times G. W is the weight M is the mass of the object, and G is the acceleration due to gravity. Now weight is a force, and we know the SI unit of force. Force has SI unit of Newton, and so weight will also have the SI unit of Newton. Looking at the mathematical expression, you can see that, let's check the relation. Weight depends on what? Mass and acceleration due to gravity. So mass may not change, but at certain time or a certain point or location in the universe, acceleration due to gravity does change. And so see, the weight of an object can change from place to place due to the change in acceleration due to gravity at different locations. Weight is also having dimension of capital M, capital L, capital T raised to the power minus 2. And so there is difference between the dimensions of the two quantities, one being scalar and the other being a vector quantity. Now the instrument used to measure weight is called spring balance. Spring balance. Now on the next slide, we have the picture of the two instruments used to measure mass and weight. The first picture is an electronic balance. Now, the specimen or the body to be measured is placed on top there. It's placed here. And it's an electronic balance. So, whatever readings, whatever measurements will be displayed on the screen here. Digital. Now, this one too is analog beam balance. It is also used to measure the mass of a body. And this one is very simple. The electronic balance is very simple. Just place the specimen or the object or the body to be measured on top of the pan there. Good. Now, we also have a spring balance. It is used to measure the weight of a body. Now, to use this instrument, it must be hung at a rigid spot. The object is hung or placed on the small curved pin here or metal here, and it measures the weight of an object. Let's take a closer look of the three instruments: the electronic balance, the beam balance, and the spring balance. Now, you should tackle this assignment. Please, make sure you go over the slides before you attempt these questions. Question 1. Define velocity and state its dimension. Its dimension. 2. In a table form, give 3 differences between mass and weight. So I said tabulate 3 differences between mass and weight. And question 3 is list 2 similarities between speed and velocity. Make sure to read over the slides before you tackle the question. Thank you.